Hey guys, this is the continuation of our typical motor control. As you can see, we've already drawn our power circuit. It's off to the right for me right now. Because we've already covered how this circuit works, I'm now going to be working over here and I'm going to be drawing up that control circuit for you guys and trying to explain some of it as we go along. I've got a really neat layout with all the wires already put together that I'm going to kind of be jumping back and forth about. And we're going to try to show you as many symbols and things as we possibly can as we're going along. I'm going to use a red pen and kind of show you in red what the control circuit's going to have into it. So now the first thing that's going to happen is we're going to steal our power from the 480 volts that are coming in. It could be like 240 or something like that. But we're going to take the high power over here and we're going to use it again in our control circuit. So first thing we're going to do is we're going to come from this one. We're going to go over, we're going to go down and back. Then we're going to come from this one. We're going to jump that one. Come over, down here. So the first thing that these two lines are going to connect to is a transformer. Remember, transformers take high voltage, bring it down to a low voltage so that we can use it. And we don't want to be coming in contact with any switches that have 480 volts behind it. So what we're going to do is we're going to start drawing our transformer. We're going to go ahead and just do an iron core one for fun. All right, so what I want to do now is I'm going to bring you guys a little bit closer so that as I'm drawing this circuit, we're able to see everything. So like I was saying, this is our transformer. It's going to go from the high down to the low. We're going to probably start up here with 480 volts, and it's going to come and turn into 24 volts down here. These are 24 volt AC right now. They could potentially be DC. This could also be run off 120 volts. It's all in what you want. So from here, we're going to go ahead and we're going to start drawing so we're going to come off of both sides. Come over here, come down. Now, the first thing that we're going to usually put in line is going to be some breaker of some sort. Not all motor controls have breakers because a lot of motor controls have that overload that we have in the power circuit, but some do. We use it mainly because if you were to wire something wrong, the breaker would pop long before you ruin my transformer. So just know that. So the symbol for breaker is usually just two dots with a kind of a half or kind of a backwards C shape or to it, depending on how it's put, and it might be, and then it's going to move on. Typically, it's drawn on the side like this. It could be drawn actually inside of the ladder. We're going to go ahead and we're going to go over. The first thing that we're going to put in here is a normally closed stop switch. And we're going to label that one stop. Hopefully you guys can read my writing. So that one's our stop switch. Now, no matter what, power's transferring into the rest of the circuit, but if we were to depress that stop switch, it would totally stop everything. Then it's going to go ahead and continue on into our start switch, which is going to be a normally open switch. And we're going to write start on that one. Start. After the start switch, we can now put whatever we needed to turn on in line with it. So we're going to go over and we're going to go ahead and add a motor coil. And we'll just call this one M1 here. And then we're going to go over into a normally closed switch. And then we're going to write overload. So then it's going to go through the overload. So what's going to happen is if that overload was to go off, it's going to actually kill the circuit, so that way that the motor doesn't continue getting juice or power or something like that. Because again, remember that motor could light on fire or have some other problems. And then we're just going to go back up. Now, for many of you guys, you can tell what's going to happen right now. Electricity is going over here to the stop switch, and it's going to be passing through. Then it's going to go into our start switch, but it's going to stop right here. So by depressing that stop switch, power is going to transfer in, it's going to energize this coil, and it's going to go back to the transformer. Now, the problem with this circuit is I have to continue holding that start switch for this motor to be energized, or this coil to be energized. And again, when I say this coil to be energized, what happens is all of these over here are going to become connected. turning that motor on. So what's happening? The motor's on, overload's working. Unless that motor's jammed up, the overload's still letting the power go. But how can we keep this thing going? There's a few options. We're going to get into some master relays and some latching buttons and things like that. But the most popular way is to create a latching circuit. Now, what we need to do is we need to figure out a way for power to continue being added to this coil. So the best thing to do is to go around it. So we're going to go ahead, we're going to go like this. We're going to add a contact in here. And the contact is going to be the auxiliary from that auxiliary on top of the motor control. So as soon as this coil pulls that motor control in, it's going to go ahead and latch this, letting power actually go around that start switch. Now that power is going to continue going over to that coil until we press this stop switch. See how that works? This is called the latching circuit. Now I'm going to go ahead and I'm going to compare it to a circuit that I've wired together for you guys. That way we can go back and forth. All right, so I have a lot of my assistants or other instructors in this class looking at schematics with students, and they're like, read it like a roadmap, read it like a roadmap. And I don't think the students can totally pick that up, that you're supposed to be going from one thing to the next, or it's going to have a turn or an intersection. You know, that's kind of what they're talking about. So what I wanted to do was build a circuit that is very common. This is just your common motor control with a latching circuit added on, which is down here. And I wanted to walk through it with you guys so that you could see that you pretty much can go from one thing to the next thing, and it almost looks identical to the schematic that we're going to be working on. So up here at the very top, you can see we have our transformer. This is a little bit bigger than I would have liked. It's kind of hard to show on the camera, but you got your transformer up here. It's going to go from, there's two wires coming off of your transformer. There's also two going into it, but I didn't do the power circuit part of this this circuit for you guys. So it's going to go from one side of the transformer, and then it's going to move all the way down here to our breaker. I tried to wire it as closely looking to the ladder logic as possible, and that's why. So I went ahead and bent the wires. That way, it kind of all fits here. It's going to come down out of the breaker right here, and it's going to move over, turn left, and go into our stop push button. Remember, the stop push button is a normally closed button or switch. When pressed, it opens the circuit, making all of this stuff de-energized. It's going to move over into the normally open switch, which is our start switch, and it's also going to be in parallel sending power down to here. So there'll be power right here at this auxiliary contact. Now, I left this thing detached because I wanted to show you that when it's on the actual schematic, it looks like it's just two drop downs to a contact. So this looks as identical as possible. But in reality, these wires are twisted, and this thing is mounted up here on our contactor. Okay? So, and that's what, when the contactor pulls in, this contacts inside here get connected. So let's go ahead and move that back down, just so there's no confusion. We're gonna talk a little bit more about this in another video. I'm gonna try to show you an easy way to just install it onto the circuit that you already have. So there's power here, and there's power all the way down here. So this is all hot all the time. As soon as we press this button, electricity is gonna pass through the switch up into one side of our motor coil. I don't know if you can see this, but our motor coil right here. On the other side, it's going to come out of that motor coil into our overload. And it's not going into our overload, it's going to a contact set of switches inside of our overload. That's a normally closed switch, and it's just made so that if this overload trips, it kills the power again. It's going to actually kill the neutral coming in. Then it's going to come out of that switch that's a normally closed switch, and then it's going to go back up to our transformer. Now, I know this looks really simple, and students have a hard time once we get out onto the trainer, but it is really that simple. The difference is that you're going to have to wire it into boxes. You might have to go around things. You might have to do really long wires or something like that. But for the most part, this is it. This is as hard as it's going to get for a basic motor control. We're going to be adding stuff onto it, but pretty much if you've got these theories and this stuff down, the rest of this class is cake. Just remember, like I said, that this is it is in series, but we're going to have it up here and connected here because the mechanicalness of this coil is going to actually pull it in. All right, so now we're going to go ahead and we're actually going to move on to the stage where we're wiring this together on the trainer. Now, again, not on the table like I did on the actual trainer. We're going to go ahead and we're going to take it from the L1, L2, go down, put the transformer in, and then from the transformer, we're going to go ahead and start wiring our ladder diagram here. Please come ask me if you guys got any questions or need help. I can honestly tell you the hardest part is going to be wiring this latching circuit right here, and it's not that bad. Just remember, you're going from one thing to the next, to the next, to the next, unless you're doing this little parallel section where you're going to add a little intersection in here, and it's going to come down into this. Just kind of keep that in your mind as you're going along. So good luck. Let me know if you guys need any help.